So in this video, which is a third video in a series of videos about mediation analysis, especially with respect to childhood and capacity project, I will talk about the classic regression approach to mediation analysis, or the conventional approach that was introduced by Baron and Ken. So for that, couple of criteria need to be satisfied for a variable to be considered mediated. First of all, change in levels of exposure. And this seems to be a much better pen. Variable significantly affects the change in the mediator. That is the path from A to T to N is affected. There is a significant, the other thing is that there is a significant relationship between the mediator and the outcome. That is the path from to Y. Now, a change in levels of exposure variables significantly affects the change in outcome. That is, total effect of the treatment on Y is significant. And when a previously, but this is a critiqued criteria, so we'll just skip that and the details of this one. And then there is in literature they also talk about another criteria which is not really necessary. Again, we are going to leave the details because our main concern is to be able to understand our output when we do the analysis, to see what it is doing, what method it is applying, where is it coming from. So when the previously defined paths are controlled, a previously significant relationship between outcome and exposure is no longer significant. That is one of the criteria too. Regardless, the two main criteria that must be satisfied are these two, number 1 and 2, that I've talked about. Now there are two estimation methods. The conventional estimation method, which is also called difference method. You fit an outcome model with and without mediator, and an indirect to identify the indirect effect and mediated effect. So that's one of the models that we'll talk about. So either you use difference method for estimation, or so in traditional structural equation methods you use product method. So difference method, you fit an outcome model with and without mediator and indirect and mediator effect. This was developed by McKinnon et al. In 1995, so you can go to the reference and figure out the details from there. The other one is a product method. In here, the indirect effect is product. It's product of two coefficients. We'll talk about it in a bit. Two model coefficients. And this is the one for which we can use Sobel's test for mediation effect. So Sobel's test for mediation effect is based on this one. So if in your software, if you see it's doing Sobel's test, it's probably applying, and it is not probably, but it is definitely applying the indirect effect, the product method, to estimate these effects for mediated effect is based on it. So going back to the conventional estimation method, which is the difference method, let's talk about difference method. So this is one of the conventional estimation method. What you're going to do is you're going to check that T is a significant predictor of Y. So you fit a model Y equal to D0 plus CT, T being the treatment, Y being the outcome, plus the error term, where C is the total treatment effect. So that's our model. Let's just box it. Then the next thing that you do is check that T is significant predictor of M. Predictor of M. So for that you're going to fit a model M equal to D1 plus AT plus some error term. Next step, regress T and M on Y and check that M is significant predictor of Y. T's predictive power and T's predictive power has reduced. So you will put a model Y equal to D2 plus C prime T plus bm plus some error term. Now C prime here is the direct effect that we are talking about. C prime is direct effect, and AB if you are using the product method, or C minus C prime if you are using the difference method, is indirect effect. So one more time, in conventional estimation method, you check that T is significant predictor of Y. Check that T is significant predictor of M. Then regress T and M on Y and check that M is significant predictor of Y and T's predicting power has reduced. And in doing so, you will be able to estimate the direct effect, which would be C prime, and the indirect effect would be AB, the product of A and B, or C minus C prime. So remember that little graph that we had. So basically what we are saying is this is our physical activity or the mediator. This is the treatment T, which is our cluster affiliation. This is A, this is B, this is Y, which is adiposity measure. Sorry. And this is C prime, which is the direct effect. So this is direct effect, and this is the indirect effect. Which is equal to AB by product method or C minus C prime, the difference method, where C would be total treatment effect. So far so good. So a little bit more. So potential outcomes framework encompasses the standard mediation analysis based on a single mediator as a special case, basically. So keep in mind that the difference of coefficient method yields numerically identical. So the difference of coefficient method, this one here, this is the difference of coefficient method. It is going to yield, when you estimate it, you are going to get the indirect effect as the estimate would be C hat minus C prime hat in the linear case, and that should be equal to A hat B hat, product of coefficient method. So let's just stop this video here. We'll talk about it in a little bit more detail in the next video. So until then, have fun watching the video.